Hi everybody, my name is Mark, and this is my new video series called Practical Networking. As I've kind of gone through and I've done a lot of studying, I looked at a lot of videos, there's so much content out there, and I'm hoping to kind of add another, resource for people to use for hopefully videos that are very, very high level, layman's terms, and really kind of communicate concepts in a way that's easy to understand. So hopefully these videos are helpful for somebody who might be, going from either a set-in home router and you don't understand like what the settings are, to somebody who, may be trying to study for your A plus, and you just need to know like the high-level basics for like what an IP address is. They're all the way from somebody who maybe you're studying for your Network Plus for the first time, or you're going for the CCNA, and you just really need kind of like that foundational understanding before you kind of really start to understand and get into some of the details. So hopefully this video is for you, but I also would explain things in a way to where we start to kind of touch on some of those concepts and underlying foundational things. So to kind of get into it, this is video on IPv4 practical networking for IPv4 addresses. So the way I kind of like think about like networking is if you've ever seen these iceberg videos, the top of the iceberg is like the super, super obvious, like common knowledge kind of things. And then as you kind of get lower, lower into the deeper underwater, you start to get into like some of the more niche topics or niche concepts. I think about networking kind of like this way. So at the very, very top, people might think like, okay, like IP addresses and subnet mask. But then as you kind of delve further and further under, there's like different protocols, different concepts, things that like aren't really so obvious to like a lot of people. So for example, when we talk like IP addresses, everybody knows what an IP address is, but does everybody know how that resolves to a MAC address? How there's different IP address classes between private and public, class A, B, and C, how subnetting works, how each of your IP address octets resolves and uses binary to determine like what that octet is, and how that uses A or P to resolve your MAC address to an IP address, which I kind of already touched on already. So the goal here is to kind of give you like that airplane, like kind of like top view. We're going to touch on and talk about some of the things at the bottom of this iceberg, but the goal is to kind of give you like a bird's eye kind of view of this. So let's go into like IP addressing. So the anatomy of an IP. We've all seen this. If you're setting up your Linksys router, this is probably very similar to like your default address. If you go to your command line right now and you run an ipconfig or ifconfig, there's a high likelihood that you're going to see something that looks just like this. So have you ever really kind of thought like, okay, like what does this number really kind of mean? How is it determined? And why, why this number is the way it is? Well, each of these like different sections of this number can go from 0 to 255, which might seem kind of odd. You might be kind of like, well, why these numbers? Like, what's special about them? You might think that like, okay, well, an integer is 0 to 255, which is kind of true, but a lot of it is because these each represent a binary number of 8 bits. So we won't get too far into like what a bit is in case it's something you haven't really heard of, but because there's 8 bits in each of these, that's why we call it octets. So an IPv4 is 4 octets. And when you talk about like a bit, all these zeros and ones, essentially every position in this little 8 chain of 8 zeros and ones, every position represents a different value. So that first one, if it's a 1, that's worth 128. That next one, if there's a 1 there, it's worth 64. And if there's a 0 in that little placement, then that means that there is nothing for that value. So like if we were to try to go and determine like how were these numbers created, well, this first one is, essentially 128 plus 64. That's how we got that 192, because that's where our ones are in that placement of that 8 bits. That next number, that 168, you can see there's a 10101000. Well, that means that we have activated that 128 spot. 64 is not activated. We activated that 32 spot. 16 is not activated. We activated that 8 spot. Nothing else has a 1 in it. So that's how we got that 168. 100, same thing. And then 1, we only have that last bit on, so that's how we got to that 1. So a little bit more detail here than you probably were expecting, but this is really good to know as you get into more concepts. The big thing here and the big takeaway is This IP address is made up of 4 different sections, 4 octets, that can go from 0 to 255. Now, as you kind of learn more, you'll kind of learn that there's different, classes, and there's public and private IP addresses. So in this case, the 192.168 range is typically a Class C private address. You also have another private address range that usually starts with 10. But for now, this is all we really kind of need to know is when you look at this IP, 32 bits total, so that's why it's called a 32-bit address, and 4 octets. So from like a metaphor perspective, you might think that like, okay, this IP address represents a placement on the map. So you might think like, okay, well, if we have 192.168.100.85, that, means that it's an address, right? I mean, it's in the name. Kinda, but not really. On its own, that is just an address. It's kind of just a number. When you kind of get into routing is kind of like more where I think like the neighborhood metaphor kind of works out, where you have a house in a different neighborhood and you use your streets to get there. But for now, your IP address is kind of like a point. But when you add in that subnet mask kind of breaks down and gives a range or gives a network that an IP address kind of lives in. So in this case, we can have one IP, and that's represented by a dot here. This dot can be 192.168.100.85. Well, let's add in a subnet mask, 255.255.255.0. What this basically means is that this IP address lives in the range of networks 192.168.100.0 to 192.168.100.255. Never mind the fact that, later on conceptually you kind of learn that, the first address is not usable because that's your network address, and the last address in the network is not usable because that's your broadcast address. But really, that tells us that this address lives in this network, and that's super important for like layer 2 switching. But for now, that's what your subnet mask represents. So if you've ever configured your computer and you've ever tried to put in an IP address and you try to troubleshoot, well, why can't I access the internet? Why can't I get to like other computers on this network? Most of the time, or a lot of the times, is because the subnet mask is misconfigured, and you will see this a lot in production networks, where somebody might go change the subnet mask value, or the initial configuration on deployment might not be done right. But that's why the subnet mask is like super important. So let's look into another example. So we have our 192.168.100.85. Well, if we use that 255.255.255.0, then that means that these other IP addresses are also on that same network. So 129 and 254. So these can all basically access each other as long as they're connected. Everything else is good. They belong in the same network. They can communicate to each other without involving any kind of layer 3 routing. So what if we change the subnet mask? And again, we won't dive too far into details into what these numbers mean, but say we change it to 255.255.255.128. Well, what that does is that adds more, bits to like the network part of like the address. So that shrinks the amount of bits that can be used for like the individual hosts or individual computers. But that kind of would break apart. Like if you just change that last octet, that breaks down this one network of, essentially the /24 into half. So each of these networks are half the size of the original network. So then we break down this, this 254 address, 255 address network into two 128s essentially. So this first section would be 192.168.100.0 to 192.168.100.127. And then our next network would be, 128 to 255. So what this essentially would mean in this example is that the first address, if we were to use that 128 subnet mask, would be on one network, and now all of a sudden that next section would be on a different network. So these would not be able to communicate to each other without any sort of routing. That's kind of confusing, but let me kind of explain to you like exactly like what that means. So I have basically a really simple packet tracer example setup. So in this setup, we have our 3 different laptops. So we have one laptop, which is our 192.168.100.85. We have our next laptop, 192.168.100.129. And we have the last one, .254, which is the last usable address in this network. If you've never used Packet Tracer, it's such a great tool. I highly recommend download it, try it out, and kind of play with it. So I've configured the first two already. So if we go and we just do an ipconfig, you can kind of see our IPv4 address is right there and our subnet mask is right there. Next one, ipconfig. And again, you can see .128, 255.255.0, that's set up as well. I have not configured this last one yet, just to kind of leave as an example. So if we go, these are like super great to use. So you can go to desktop, command prompt, and that opens up like a simulated command prompt right there. Anytime in networking, if you're in like any kind of device, Juniper, Cisco, whatever you're using, usually a good place to start would be a question mark, and that's usually to give you like a good example of like some sample commands you can use. So in this case, we want to set up our ipconfig. So again, if we do ipconfig and a question mark or slash question mark, usually that kind of gives us an example of how to use the command line there. So in this case, ipconfig, and then we see like our IP and our subnet mask in this next part with default gateways and optional. We won't use default gateways right now, but to configure this last laptop, 192.168.100.254. And then we'll do our subnet mask, and there we go, it's configured. So each of these three laptops right here that correspond to like our last slide, so this 85, 129, 254 are configured. So based on this example, they should all be able to communicate with each other and ping each other. So let's see. So from this first one, or this last laptop, let's see if we can ping the first laptop. So we'll just do a ping 192.168.100.85, and looks like they're reachable. And let's see if we can ping the other one, .129. If you hit up, that goes to usually your last command that you ran. And looks like that next one is not reachable. So let's kind of see what's going on there and why this isn't working. .129 ipconfig, and oh, looks like that one is actually put on the network address. So again, network addresses are not usable. So a great example there. So let's change that to a .9. Or wrong address. So let's get into something else I'm about to do. So yes, there we go. Now that we corrected it, it's all good and it's pingable. So, all right, we're all good here. Each of our computers can ping each of the other ones. So we got full connectivity the whole way around. So what if we changed this second computer? Let me pull this up. What if we change that .129 and we give it that 128 address? What that will do is that will put it in the second network, and let's see what it can kind of connect to from there. So we're going to go ahead, ipconfig, same exact thing, but we're going to cut that network that it's in half. So let's do that. Let's see what it can reach. So let's try pinging that third laptop real quick. Interesting. So as you kind of see, like, it works. It can reach that network. Why is that? Well, anything that's not in that network, the laptop will try to send to like what's called its default gateway. So in this case, if you look at the bottom where like the purple is, if we were to use that 255.255.255.128, the network range is 192.168.100.128 to 192.168.100.255. So because they're in the same network, that 129 will not send that packet to its default gateway. What it'll do is it knows that 254 is on the same network, so it will just layer 2 switch it, basically to where it needs to go. There's no layer 3 routing that needs to happen. It can reach that computer, and that computer should be able to ping back, and you see those response pings. So let's go ahead and confirm that real quick. So we're on computer 3. Let's see if we can ping that second computer. Yeah, so we can ping that. So if we look again at that diagram, even though that 85 is technically closer, let's see if that second computer 129 can reach that .85. So we are on 129. Let's go ahead and ping 192.168.100.85. You'll notice that even though that second computer has the wrong subnet, it can still ping that third computer to .254, but it can't reach that first computer that has the closer IP address. And that's because the computer knows that if it's not on the same network, it's going to try to send that packet to the default gateway, which isn't configured. There's no routing between the two, so that that packet just won't have a destination. It won't work. Let's see if we can ping computer 3 from computer 1. These are furthest range away, furthest away. Ping 192.168.100.254. Yep. So that third computer, because it happens to be in the same .128 as computer 2, even if it had that same subnet, they just happen to exist on that same network. The fact that the subnet mask is misconfigured, this causes so much confusion when you're out in the field and you're troubleshooting, because you can wonder, like, okay, I'm sitting at a computer, why can it reach some computers and not others? Well, that's because sometimes things can happen to line up. It just so happens that if we misconfigure that subnet, that second and third computer are on the same layer 2 network. So there's no layer 3, involved. Uh, because they're on the same network, they can communicate with each other. And if you're trying to troubleshoot, then you'd say, like, well, how come I can't ping 129 to 85? Well, because where that subnet is divided, that first computer would be on a completely different network, so that they would not be able to reach each other. These are like those configurations and those things you really have to look for, like, out in the field, because it's something that will cause a lot of confusion, a lot of troubleshooting, a lot of wasted churn trying to troubleshoot that. So let's go ahead and flip back and let's correct that subnet now on the second computer. So if we correct the subnet back to .0, we should be able to ping both computers now. So let's go ahead and ping .85. Yep, so there was just a misconfiguration there. Should be able to ping the .254. So all that to say, like, that's why your subnet mask is really important. So if you're ever setting up your home router at home and you're like, why is this not working? How come I can't communicate, like, between the two? That the important thing to know is your subnet mask, it defines your network boundary. So if your network boundaries are set up incorrectly, you might have places in situations where they don't line up. You might end up in weird situations where you set up, you misconfigured one computer that just happens to exist in the same boundary as a different host, and that's why it can reach some hosts but not others. So your IP address is one point in the network, but the IP address and the subnet mask will define, like, what that network is. It will define the boundaries of that network. So all that to say, in summary, an IPv4 address consists of 4 different octets. They're called octets because each of those sections consists and is made up of 8 bits, and that's how you get that range of 0 to 255. On their own, IP addresses don't tell you much, but add in the subnet and you get a point that exists within that network. It defines the boundaries. And because of that, subnet masks are important as they determine that network boundary. So without that subnet mask, or if it's misconfigured, you're probably going to run into, like, a ton of issues. Um, Thanks for watching. This was video 1. If you enjoy this, like, comment. Hopefully these kind of get better from here. But again, thank you for watching.